So in previous videos, I've gone ahead and just solved these LeetCode problems on the fly. I think it'd be more beneficial to take an existing solution and then talk through maybe why it works for one of these more complex ones. So combination sum here, it is given an array of distinct integers, candidates, and a target integer, target, return a list of all unique combination of candidates where the chosen numbers sum to target. You may return the combinations in any order. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. It is guaranteed that the number of unique combinations that sum up to the target is less than 150 combinations for the given input. So looking here, you have candidates, which is 2, 3, 6, 7. The target is 7. You have the explanation there as the output. And the reason being is that 2 and 3 are candidates, and 2 plus 2 plus 3 equals 7. Note that 2 can be used on multiple times. There are only 2 combinations. Input here, you have 2, 3, 5. Target is 8. 2, 2, 2, 2 equals 8. 2 plus 3 is 8, and 3 plus 5 is 8. Lastly, down here, you have candidates equals 2. Target equals 1, and you're going to get back an empty list because the candidates will never equal target. So you have a couple of constraints here. One of the constraints is that 1 is less than or equal to the candidate's length, which is also less than or equal to 30. The elements at each index position are going to be between 1 and 200. All elements of candidates are distinct, so even though it's a list, you can think of it as a set. And then 1 is less than or equal to the target, which is less than or equal to 500. Okay, so let's go ahead and take an existing solution here and copy and paste it over, and then I can go ahead and talk through maybe why this solution works. Okay, so I went ahead and copied over a solution. Let's go ahead and talk through maybe why this works. So you have your result, which is a list, and then you have unique as a dictionary or a set. I mean, I think that it's a dictionary because I think that sets are instantiated with the built-in functionality of set, open parenthesis, end parenthesis. You have your candidates, which is going to be a list of sets of candidates, which I don't necessarily think is completely relevant here. I don't think you have to do that given that we have, where is it? Yeah, so I don't think that this line here is completely necessary. I think that if we went ahead and removed this line, nothing really would be changed. So I think that that's an unnecessary addition here. You have all elements of candidates are distinct, so there's really no reason to make it a set and then convert it back to a list. I think this is just wasted IO. But going ahead, they went ahead and created a helper method called solve, in which they're passing in all the candidates, the targets, the result, and unique to, and then just returning result. So what they do here in this solve is that they have, it's a self because it is part of a class. You have candidates, target, result, unique. You have I equals 0, which is interesting. More to come on that. Current equals open end list. So it's an empty dictionary, which sounds to me like they might end up doing some type of recursion, but I don't. Oh, so there's the recursion right here. You have to be really careful whenever you do this in Python. This will never actually, it's kind of strange, but if you instantiate a method or a function as an empty dictionary as a default value, it doesn't get reset. So it kind of tracks where things are in, like, as the program keeps continuing to call it. This is not a deep copy. This is an actual value that gets updated as you call this function. So you need to be really, really careful on that. I'll try and leave a link somewhere in the description talking about why this is a bad thing to do and that you shouldn't do it. But looking here, you have if target is equal to 0, then temp is equal to a for loop where I is for I in current, and current is equal to an empty list in this case, at least for the position 0. So I would think that this will just be 0. Temp 1 equals temp. Okay, so it's just gonna be an empty dictionary. Temp dot sort. It's not going to do anything. Temp equals a tuple of temp. Again, this is going to be empty. If temp not in uniques, unique sub temp equals 1. Result dot append temp 1 return. Okay, so if target is equal to 0. Oh, I mean, that makes sense then, because then it's just saying this is your edge case or your base case where you're continuing to go ahead, and it looks like it's probably going to decrement target if I had to guess somewhere in here. append candidates, that's solved. Yeah, so it's going ahead and decreasing target every time that it iterates through. Not a bad idea, honestly, pretty cool. If target is less than 0, just return, because we can't really do anything there. And then otherwise, we're going to go ahead and say for x in range I, comma, len of candidates. So current dot append candidates sub x. So I, comma, len of candidates. I is going to be instantiated as 0. Length of candidates is just going to keep getting smaller because I think somewhere in here we are popping. Yep, we're popping right there. So self.solve candidates, comma, target minus candidates at that position, result, unique, I, and current. Current.pop, len of current -1. I don't really understand why you would need to do this. I would think that you could just say -1 and then it would just know. Length of current. How is this any different than just dot pop? So there's a couple things that can probably be improved upon functionally, but that's pretty much a gist as to why the solution would work, and it would just keep on recursively calling this up here and updating this like results thing, making sure that it is of course unique before it goes ahead and adds them in. Let's go ahead and submit the solution. Let's see what we're sitting at. So it's judging, it's speeding up, so it's pretty slow. Let's go ahead and remove this line here. I would think that the solution still works just as fine. The memory is crazy. Like it's almost better than 100% of all other applications. It's just not super fast, which is not a huge surprise, honestly. I think that what you can do here is you can literally just go like this, dot pop. Yep, and so we're already starting to see that this is coming down drastically. We've almost decremented it by half of its runtime, which is fantastic. Honestly, all that stuff does add up in the end. So next up here, is there any other place that we can go ahead and trim out the fat, as they would say in Horrible Bosses? So I personally like to use the juggler set, which, if you don't know what that is, it's basically this. Taking 2 lines and making it into 1. It's really not necessary. It's more of a like stylistic thing, but I think it looks a little prettier. So, don't at me. Current. I don't like how this is set to this. I would actually prefer it if they literally just did I and current like that, and then when they call .solve, they can just say 0. And then an empty list. And then essentially what that would do is it would just go downstream. I think that this would actually be better than doing it that way, because I don't think that the default keyword, it's going to be a little... I'll try and leave a video too, like I said. I'll leave it at that much, but let's go ahead and submit this code, see how this is operating. Judging, so we're still like 602 milliseconds. We've gotten a lot slower or a lot less efficient in memory, which is kind of wild to me. I'm not really sure why that would be the case. So for x, current.pop.solve, target minus candidates. If target is less than 0. Okay, if this is equal to 0, why would these two need to be separate? That's my question. For I temp. Tuple, unique temp sub 1. Okay. I guess. I don't really understand why these two would have to be 2 separate if statements. But I mean, I guess that all makes sense from like a high level overview. This is basically a recursion problem where you're taking the target and you keep on calling itself, decrementing it over and over and over again until you reach the final output solution, which makes complete sense, honestly. So I'm not totally sure why. Okay, so it's not solved. It just keeps on going ahead and doing this until it gets to the point where it can no longer pop out any more elements. That makes total sense. Let's go ahead and submit it one more time, see what our final runtime and memory allocation is at. So it looks like after doing some fixing up and stuff, we actually made it a lot less memory efficient. However, we did make it quite a bit faster. So that is a high level overview of what the combination sum looks like. Let's go ahead and grab another problem here, and I can talk through another solution. So for our next problem here, it is basically a level up in difficulty for the combination 2. So it basically is not going to be a level up in difficulty essentially, but basically given a collection of candidate numbers, candidates, and a total number target, find all unique combination candidates where the candidate number sum to target. Each number in candidates may only be used once in the combination. The solution set must not contain duplicate combinations. So you no longer have the distinction of all elements, and also each element in the list can only be used once. So going ahead and copying over this solution here, and then we can talk through it. Okay, so talking through this solution here. So you have a results list here, which makes total sense. You sort out the candidates, which I think is also a pretty wise thing to do. You create this helper method, which you're going to be passing in results, candidates, target, combination, and start. More to come on that. So again, this person definitely knows a little bit more about how default keywords are set in Python. So they went ahead and created it like this as such. I think that's a very wise thing to do. If target is equal to 0, results.append list combination. Okay, then return. If target is less than 0, just return. Otherwise, go ahead and do the recursion step. So basically you're going to have a start position, which will be passed in here. Your start can go ahead and keep on incrementing up by 1. That's something to be called out for. And then in the initial one, it goes ahead and calls it out as 0. If I is not equal to start and candidate sub I, if I is not equal to start and candidate sub I is equal to candidates I minus 1, continue. So if I is not equal to start, so we're not on that first element, and candidate sub I is equal to I minus 1. Okay, so it's the same element as the one before, so we can go ahead and skip it. Combination.append candidate sub I, self.helper results candidates target minus candidate sub I, combination I plus 1, combination.pop. So this one is definitely just a way more efficient way of doing things. The only caveat is that it had to take into account the fact that it cannot have duplicates in there of like using the same number over and over again. I love the solution. I think this is going to be pretty fast as well. Okay, so it's 134 milliseconds, 29.1% faster, and 93.32% more efficient on memory. I love the way that feels. Go ahead and have combination.pop, combination.append. I'm a little curious why you need the list wrapped around. I guess maybe it wants it to be a list of lists. Yeah, it does. Okay, so that makes sense as well. Yeah, this just looks great. I don't have any really complaints about this. I feel like the person definitely knew what they were doing. And overall, this was actually a pretty simplistic way to handle this. It's very semantic. You know, it's got a helper function. It doesn't do any type of oddness when it comes to Python instantiations. Let's go ahead, since we have time left over in the video, let's go ahead and talk about why it's a bad idea to set keyword values. Okay, so I went ahead and read through this a little bit, but essentially what we have here is a Stack Overflow article that I will have linked down in the video. But it's going to be talking about why is the Pythonic way to avoid default parameters that are empty list. So sometimes it seems natural to have a default parameter which is an empty list, yet Python produces unexpected behaviors in these situations. If, for example, I have a function that is doing exactly what I had said before that you should probably not do, the first time it is called, the default will work, but calls after will update the existing list. Like I said, this is not a deep copy of what you're doing. This is actually like a set in stone that just kind of gets carried out throughout your entire program. So you want to go ahead and remove that from whatever applications that you have if you ever ran into like caveats and stuff. So here you go. This is like a different approach to it. So basically what you want to do is you want to handle it like this. This is definitely the preferred way. I totally agree with the solution here. And so the doc says that you should use none as the default and explicitly test for it in the body of the function. It is better to say if working list is equal to none, or if okay, so that's just dumb. But yeah, so basically I think that we can go ahead and click on this link, see how this goes. Default parameter values are elevated from left to right when function definition is executed. This means that this means that the expression is evaluated once when the function is defined, and the same pre-computed value is used for each call. This is especially important to understand when a default value is a mutable object, such as a list or a dictionary. So that is going to be your key indicator right there. If the function modifies the object ig or eg by appending an element to the end of the list, the default parameter value is in effect modified. So this is exactly what I was referring to. You need to avoid doing this at all costs. So hopefully this video was a helpful video for you, for those of you that like to use Python or are just learning how to use Python in general. But as always, if you like the content, feel free to like, comment, subscribe, helps me out a ton, and I'll catch you in the next one. See you.